Hi, today I'm going to go over 118 equivalent representations of trig functions. So first, the Pythagorean identities. You know Pythagorean theorem is a squared plus b squared equals c squared, and you know that's used on a right triangle. There's your c, here's your a, here's your b. To find the length, we use that in the beginning of the year. So now look at this. This is the unit circle because the radius is 1. So that's the unit circle. So consider the diagram of the first quadrant and the angle theta, which intersects the circle at xy. Here's the value of your radius, goes to xy, and we know all these values when we know different thetas. But use the Pythagorean theorem to prove the identity of sine squared plus cosine equals 1. So here we have our right triangle, and we know that if I square the legs, I get the hypotenuse squared. So to prove that for trig, r squared is just 1, right? 1 squared, which is just 1. X in the unit circle is cosine and y is sine. So I could just replace this and say cosine squared is x plus sine squared equals 1 squared. Now, you could write it like this, which this x is a different value than this x, but cosine squared, or not x, let's use theta. Cosine squared plus sine squared equals that, but usually when we are using this, sine is king, sine is first, even though it's adding sine squared of theta plus cosine squared of theta equals 1. Okay, so that's an identity you will use a lot. I think I may have showed you in the notes one of the days, but we proved it right there because of this right triangle. Divide the identity by cosine squared and rewrite a new form using tangent and secant. So I'm going to write it first. I started writing cosine first. Now we're going to divide by cosine squared. So cosine squared, since it's addition, we have to divide every term. Since it's an equation, we have to do same thing to both sides. So I get sine squared theta over cosine squared theta plus, this is the 1, equals 1 over cosine squared theta. Now, here we have some inverses. Remember, tangent is sine over cosine, and secant is 1 over cosine. So this becomes tangent squared of theta, because it's squared, but it's still sine over cosine, or y over x, plus 1 equals 1 over cosine is secant squared of theta. All right, number 3, divide each term by the Pythagorean theorem by sine squared. So let's see the identity, not the theorem, sorry. The identity, so let's see sine squared. So we're going to start with sine squared theta plus cosine squared theta equals 1. Divide by sine squared theta. Now, if tangent is sine over cosine, cotangent is cosine over sine. All right, like that. cosine over sine, or x over y. And then cosecant is 1 over sine. Remember, these seem like they should start with the same letter, but they don't. That's how I remember which one is which. So when I divide these, I get 1. When I divide these, I get cotangent squared theta. And divide these, I get cosecant squared theta. So I'm going to grab a highlighter and just highlight the final identities that we got in each of these. So there's that one. There's that one. And that one that you should memorize. Okay, that's page 1. Let's go to page 2. So page 2, they give us a couple other identities. We have the sum identity for sine and the sum identity for cosine. So what it is doing is getting two angles that you add together. You could get the sine of alpha, so these are two different angles. Sine of alpha, cosine of beta, plus cosine of alpha, sine of beta. And the cosine is the same. You start with cosine, but it's not the same. You start with cosine, you subtract sine of each of them. Sine's the tricky one because you start with sine times cosine plus cosine times sine. Okay? So they're a little different. All right. Let's go to where you're going to use it for 5 pi over 2. So that is one angle, and we're going to break that up into two angles. So looking at our circle, 5 pi over 12. I think I said 2, sorry. 12. So 12, all these numbers go into 12. So let's just break it up and see which ones we get, right? We have a divide by 3, divide by 4, divide by 6, divide by 2. They're all divisible by 12, into 12. So 5 pi over 12, we could think of that as 2 pi over 12 plus 3 pi over 12. So now if we reduce that, that is pi over 6 plus pi over 4. Now we have two angles that we identify in the first quadrant, pi over 6 and pi over 4. So those are the two, one's going to be alpha, one's going to be beta. So we're going to get the sine of 5 pi over 12 is the same as the sine of pi over 6 plus pi over 4. And then using the identities, I do sine of the first one times cosine of the second plus cosine of the first one times sine of the second. Now using our circle, you could either use square root of 2 over 2, but remember this is simplified, we rationalize the denominator, but the value that we started with those was 1 over square root of 2. 1 over square root of 2. And then when you multiply by square root of 2 over 2, we get this. But the value, the simplified value, is this. That's without the rationalized denominator. So pi over 6, the sine, is 1/2. Pi over 4, the sine is square root of 2 over 2, or I'm going to use this. Cosine, pi over 6 is square root of 3 over 2. Cosine, pi over 4 is that. So first we do sine of pi over 6 is 1/2 times cosine of pi over 4 plus cosine of pi over 6 times sine of pi over 4. You could use a calculator to check. So we get these are 1 over 2 square root of 2, and this is square root of 3 over square root of 2 over 2. So since they have the same denominator, I could write that, and I get 1 plus the square root of 3 which if you divide these, divided by that, you get about 0.966. That's rounded. If you don't use 1 over square root of 2, you end up with, I'll put an or, 1 over 2 times square root of 2 over 2 plus square root of 3 over 2 times square root of 2 over 2, which equals, this is 4, because we have to multiply those denominators. This is 4, so we get all over 4 square root of 2 plus square root of 6. And it still works out to that, but it's not as simple as this. Okay, so either one, you get to the same place, but this one just looks simpler. This is actually correct not to have a radical in the denominator, but okay. So cosine of 11 pi over 12. So I'm going to show you the identity while I write it out. There's the cosine identity. So 11 pi over 12, that's the same as 9 pi over 12 plus 2 pi over 12, which is 3 pi over 4 plus pi over 6. So we're going to say the cosine of 3 pi over 4 plus pi over 6. Oops, cosine of 11 pi over 12. There. Okay, so we're going to use this identity, so we get the cosine of 3 pi over 4 times the cosine of pi over 6 minus sine of 3 pi over 4 sine of pi over 6. 3 pi over 4, again, but the only thing is the cosine's negative over here. I'm going to use square root of 1 over square root of 2, which is square root of 1, but 1 over square root of 2. So 3 pi over 4 is negative 1 over square root of 2. Cosine pi over 6 is square root of 3 over 2 minus sine of 3 pi over 4, which is a positive y, so it's this positive, times sine of pi over 6. So again, in the denominator, we have the same thing, 2 square root of 2, 2 square root of 2. So I could write the numerators together, negative square root of 3 minus 1 times 1 over 2 square root of 2. And putting that in a calculator, either you need to have the vertical division or do this first, then enter, then divide. But you should get about negative 0.966. All right, sine. I'm going to show you the sine identity again. Sine times cosine plus cosine times sine. So we're going to use pi over 12. We don't have anything to break up, so we're going to have to use subtraction now. That is 3 pi over 12 minus 2 pi over 12. So this is going to be our beta, this is going to be our alpha. You could say plus minus, but when you add a negative, it's subtraction. So we're going to get sine of pi over 12 is the same as sine of 3 pi, oops, I didn't reduce them. 3 pi over 12, let me go backwards, is pi over 4. 2 pi over 12 is negative pi over 6. So that equals sine of pi over 4 minus pi over 6. So we're going to take sine first, pi over 4, times cosine of negative pi over 6, plus cosine of negative pi over 6 times sine, oh, sorry, I don't switch those. It's pi over 4. You keep alpha and then sine of beta. So it's alpha, beta, alpha, beta. Okay, so then sine of pi over 4 we've already gone over, but negative pi over 6 is down here, which is the same as pi over 6, but your y is negative. So it's negative 1/2 for the sine. So sine of pi over 4 is 1 over square root of 2. Cosine of negative, so that's the x, so the x doesn't go negative. So it is square root of 3 over 2. Plus cosine of pi over 4, 1 over square root of 2, times sine, this is where it goes negative, 1 over 2. So again, we have the same denominator, so I'm just going to write it once. Here I have the square root of 3, negative 1, so it's a minus 1, which in the calculator from here comes out to 0.259. Number 4, let's look at cosine real quick. So it's cosine alpha beta minus sine alpha beta. So we need negative pi over 12. How do we get a negative? We have to have a bigger number be negative. So we're going to start with 2 pi over 12 plus a negative 3 pi over 12. So you could think of it that way also. Just know the second one has the negative, so that's your beta. So that is pi over 6 minus, and then negative 3 pi over 4. So here's your alpha, here's your beta. Okay, so cosine of negative pi over 12 is the cosine of pi over 6 minus pi over 4. So we take the cosine of alpha and beta first. And we subtract the sine of alpha beta. Nope, that's not a 6. The first one's a 6. Beta is a 4. I did it again. Okay. So now cosine of pi over 6 is square root of 3 over 2. Again, we're going negative, so it's down here where x is positive and y is negative. So when we ever have sine, we have to do a negative, but cosine is positive. Minus sine of pi over 6 times cosine of negative pi over 4. No, this should be a sine. I'm so sorry. Sine and sine. Cosine alpha beta, sine alpha beta. It's up here. So sine of negative, that's when we go negative, and it's negative 1 over square root of 2. We have the same 2 square root of 2. That's square root of 3. That's negative 1, but we're subtracting, so it becomes a plus 1. And if you put this in the calculator, you get about 0.966, which you may recognize from number 1. Okay, now page 3. Page 3 is deriving double angle sum identities. So double angle means multiplying by 2. So we want to let alpha be theta and beta be theta. They're the same angles. So what does it mean to double? We're going to do this for sine. So we're going to do sine. So we're going to double theta. Okay? So I'm going to write theta plus theta, which is sine of 2 theta. So right here, we're going to use the identity we just used, which is not on my printout. Where is it? There it is. Okay, so remember sine of alpha plus beta is sine of alpha cosine of beta plus cosine of alpha sine of beta. So we're going to get sine of theta cosine of theta plus cosine of theta sine of theta. So we have the same thing twice. This is multiplication, so it is just switched around, but we could have written it like this. Oh, times. So it's the same thing on both of them. So we have one of them plus one of them. Same thing, sine, cosine, sine and cosine multiplied, which equals two of them. Sine theta, cosine theta. So let me get my highlighter. Sine of 2 theta is 2 sine theta cosine theta. I didn't highlight on the other page, but you can. These are important to know. Okay. Some identity for cosine. We're going to do the same thing, but using the identity for cosine, which is some identity. So we have, so cosine of 2 theta equals cosine of theta plus theta. Now remember to use the sum identity. Cosine of alpha plus beta is, you do the cosine first, then sine. No, cosine first. I just said it. Minus the sine of alpha, the sine of beta. I just highlighted it and I just said it and then I didn't do it. So cosine alpha, cosine beta minus sine of alpha, sine of beta. Okay, so now we have theta, which is the same angle twice. So if we're going to break it up, we're going to do this one right here. Cosine of theta, cosine of theta, minus sine of theta, sine of theta, because both our angles are the same. And when we do that, if you get something and you multiply by itself, you square it. So this is not the Pythagorean theorem. This is subtraction. So the cosine of 2 theta is cosine squared minus sine squared. So you could write them in here for sine. So we write sine of double angle is 2 sine theta cosine theta. Cosine for double angles is cosine squared theta minus sine squared theta. Okay, one more, which I just highlighted up here, there, but they are right here. We wrote them in. You should write them in right here. So in previous problems, we found that pi over 12 is this, sine of pi over 12, and cosine of pi over 12 is this. Prove that the double angle sum for sine with theta equals that yields the same as sine of pi over 6. Sorry, taking a second to think of why pi over 6. So I haven't done this in class. I'm doing it now for the first time. Okay, let's just jump in. So sine, use a double angle for sine. So we know sine of 2 theta is 2 sine theta cosine theta. So we're going to double it. Oh, that's where they got pi over 6. So if we're going to use theta as pi over 12, so sine of 2 times pi over 12, there's your pi over 6, is 2 sine of pi over 12 cosine of pi over 12. I'm just going to write sine of pi over 6 because 2 and the 12 cancel to 6. We know what this value is from the page before, and that's what they gave us right here. So it is 2 times square root of 3 minus 1 over 2 square root of 2, and square root of 3 plus 1 over 2 square root of 2. Which is 2 square root of 2, square root of 3 minus 1, square root of 3 plus 1. Your 2's cancel. When you multiply this by itself, that's squared, so that becomes 4. Okay, so square root of 2 times square root of 2. We're not adding, so we shouldn't have just one denominator. We're multiplying this times this. So you get 4. Now, in the numerator, you get difference of squares. When you multiply and you have an adding and a plus and a minus, and they're the exact same thing, so the middles drop out when you do a quadratic. So you get square root of 3 times square root of 3, which is 3, minus square root of 3 plus square root of 3, that's where it drops out, and negative 1 times 1, which is 1, over 4, which is 2 over 4, which equals 1/2. Which, on the left side, if I had kept it up, it's sine of pi over 6 equals 1/2. Is that true? Pi over 6, your sine is 1/2. So we proved it. All right, let me know if you have any questions. See you in class.